Hello, this video is about how to use the standard normal distribution tables. They all look very similar to each other, and you can find one on Google. Doesn't take much. Usually there's going to be two possible things you're going to want to do. You're either going to want to calculate a probability or estimate a probability, or you're going to want to calculate a critical value. If you want to calculate a probability, you have to be given the z-value or the critical value. If you want to calculate a critical value or a z-value, you're going to have to be given a probability. So let's start with calculating a probability. You'll need the z-value, and once you've got that z-value, there's a three-step process. First, you're going to have to find the units in the tenths digit along the left side of the table. 2, you're going to have to find the hundredths value along the top of the table. And 3, the probability is going to be at the intersection of that row and that column. Let's see what that looks like. So here's a normal distribution table that I pulled off the web. I'll make it a little bit bigger, but not much. This is nice in that it shows you that this blue area is the probability, or is that area that you're actually calculating here at this table. So let's pretend that we want to calculate the probability corresponding to a z-value of negative 1.99. Negative 1.99. So the units is the 1, the tenths is the 9, and the hundredths is the 9. So along the left side, you'll look for negative 1.9, and along the top, you'll look for that last 9. So go down here, negative 1.99. There's negative 1.9. And then we go across to the 9, which is the last column. So here's the probability of negative 1.99. And technically, that 0.0233, that's the area under the normal curve to the left of the value negative 1.99. And that's all probability is. It's the probability of z being less than a negative 1.99. Another example. Say that we want to find the probability corresponding to 1.11. Make them easy numbers. 1.11. So we'll look for 1.1 along the left side and 0.01 along the top. Here's 0.01. It's the second column, and that's also very typical. So we're looking for 1.1 along the left side. Going down, going down, going down, going down, going down, going down, going down. Oop, there we go. 1.1, 1. So that's the probability. That's the probability corresponding to a z-value of 1.11. And what that 0.8665 is the probability that z is less than or equal to 1.11. In other words, it's this area here in dark blue that's to the left of 1.11. Let's go with a final example. I want to find the probability corresponding to a z-value of negative 8.77. Negative 8.77. Negative 8.77. So the negatives are on the other page. Negative 8.7. Oops, this only goes to negative 3.9. But if you notice, as you get more and more negative, these probabilities get smaller and smaller and smaller, to the point that negative 3.99 is 0. So that would tell us that the negative 8.99, or whatever it is going to have a probability associated with it of 0, which makes sense because that probability is going to be the area of this region to the left of negative 8.99, which is way out here. So that probability is really, really small. So in other words, if you're off the table too small, the probability is going to be 0. Conversely, if you're off the table too big, probability is going to be 1. So let's find the probability corresponding to a z-score of 10. Looking for 10 over here, 10, 10, 10, 10, 10, 10, 10. Nope, off the table. Notice as the z-value increases, the value in the probabilities here, the values in the body of the table also increase. So it's probability corresponding to a z-score of 10 is going to be essentially 1. So keep that in mind. If you're off the table too high, probability will be 1. If you're off the table too low, probability is going to be 0. And then with between those two, if you're in the table, you can find the probability in the body of the table. Okay, so that was calculating probability given the z-value. So let's see the other options. calculating a critical value given the probability. This one's a little bit more difficult because you have to find the probability in the body of the table. Remember, the body of the table is all about those probabilities. So if you need to calculate a critical value or z-value, you look for that probability in the body of the table, and then you pick off the z-value along the left margin and the top margin. The left margin will give you the units in the 10th digit, and the top margin will give you the 100th digit. So, for instance, let's find the z-value or the critical value corresponding to a probability of 0.01. So we look for 0.01, the probability of 0.01 in the body of the table. 0.01, these are all too big, so go to the other page, look for 0.01. Here's a 0.0107. Okay, 0.01 is going to be between these two values. It's going to be pretty darn close to this 0.0099. So since that is our probability, the z-value corresponding to it will be negative 2.33. Negative 2.33. Another example. Let's find the z-value corresponding to the probability of 0.025. So we look for 0.025 on the inside of the table, and it's right there. Actually, it's exactly right there. It's kind of rare. And so the z-value corresponding to that probability will be negative 1.96. Negative 1.96. One more example. Let's find the z-value corresponding to a probability of 0.001. 0.001, 0.001, 0.0. There's one. Ooh. Here's a 0.001. Here's a 0.001. Here's a 0.001. So which should we choose? Well, on the one hand, any of those will work, but most likely the middle one's going to be the best because of rounding. So this will be the middle one. So the z-value corresponding to that probability is negative 3.09. And that's how it works. That's how you use these normal distribution tables. They're kind of tricky. That's why a computer is so valuable in this. You don't have to go to the tables to find those values. But when all you have is the table and you're stranded on a desert island and you absolutely positively have to calculate a critical value given a probability, this is how you're going to have to do it. I hope this was helpful. It's going to take a little practice in using this, but it's going to be worth it in the end, I think. So enjoy and have a good day.